Well, thank you very much for the introduction, Dr. Sundberg, and thank you all for being in attendance this morning, where we'll have the opportunity to briefly describe some of our latest recommendations coming out of our K-State Feed Safety Research Team, as well as hopefully provide some recommendations as an industry that we can have a general discussion and hopefully be able to move forward as an industry. So when we think about feed safety as a broad topic, that we'd like to think of this topic in a series of a cascade. Throughout this cascade, various aspects have been addressed throughout various research activities. When we think about whether feed or feed ingredient can become contaminated and ultimately lead to infection, the first step in this cascade would be to determine or address, is it likely to become infected? If an ingredient or feed is likely to become infected based on the agricultural practices and the way it is manufactured, it is then next very important to determine whether or not that pathogen can survive. Subsequently, it's very important to then determine whether or not if it is infectious, and subsequently how can we prevent contamination of that feed or ingredient in the first place. And finally, if a feed or ingredient do become contaminated, what can we do as nutritionists, veterinarians, and feed producers to help mitigate the risk of disease transmission? So going through the feed safety cascade, we'll talk about all those various aspects throughout our discussion here this morning. So to begin with, is a feed or feed ingredient likely to become infected? So as feed manufacturers, swine producers, veterinarians, and nutritionists, what ingredients do you utilize that are at risk of getting infected with a specific pathogen of concern? And we'll go through a series of examples. And like anything, it's a spectrum. Nothing is black and white. But we do help classify the risk of becoming infected, either being highly or more higher risk or a lower risk of infection. An example of a higher risk of becoming infected we could classify as rice hulls or corn cob or various agricultural products that are grown in regions where a foreign animal disease is present, as well as in combination with the way those products are manufactured, whether it be drying corn on the side of a road or the basic agricultural practices of a region. If we contrast that to something we would consider to be lower risk, something synthetically derived in an enclosed manufacturing facility, such as synthetic amino acids, although potentially from the same FAD-infected countries, we believe are lower risk, one, because the way they are manufactured and stored, as well as the way they are packaged in individual single-use bags that are subsequently disposed of. So this is how we help to think whether or not certain agricultural products would be at a higher or lower risk of becoming infected. Next, it's important to determine whether or not that pathogen can survive within the feed or feed ingredient. So the table presented is a summary of the most commonly used ingredients in our swine diets. And much of this data has been adapted from the good work of Dr. D and others, as well as some of our work at K-State. And the red indicates that the detectable virus was present after a minimum of 37 days, whereas green, there is non-detectable virus present. So the takeaway from this slide is that although we do have a tremendous amount of great research, there still is a significant amount of information that we don't know. There's still a lot of white boxes on that graph that ultimately don't paint the full picture for the whole feed industry as a whole at this time. So as the Nutrition and Feed Safety Group at K-State, we'd like to discuss some observations about ingredients that we believe tend to harbor virus better than others. And we believe those ingredients are high protein content, especially natural-based protein. And next, we believe that those ingredients that have a relatively large surface area to mass ratio are better at harboring virus relative to those with lower ratios. The image on the top right is a scanning electron microscope image of the coat of a whole soybean, whereas the image just below is the same magnification of soybean meal. As you can see, there's a much greater surface area within the soybean meal, which we believe allows, whether it be through exposure of proteins, specific amino acid, allow for the virus particles to gravitate and stay attached to those various particles much better when they have a greater surface area. We also believe that porcine-based ingredients do tend to harbor various viruses better than non-porcine-based ingredients, as well as those micro-ingredients. One example would include vitamins that are produced with a carrier. Those carriers can include rice hulls or ground corn cobs or others, and we believe that they are at a greater risk due to those carriers and the way they are produced. Next, we'll go through some of our data specific to porcine epidemic diarrhea virus to again illustrate whether or not specifically PED can survive based on specific ingredients. The graph on the left, in both graphs, on the x-axis represents the day post-inoculation with a known amount of PED, and on the y-axis is a cycle threshold. An increase in CT value indicates a reduction in the amount of quantifiable genetic material. As you can see in both data sets, there is a difference over time based on the specific ingredient, such that we believe that those non-porcine-based ingredients, such as porcine-free complete feed, do have a reduction in the amount of quantifiable genetic material over time relative to other ingredients. Additionally, when we consider whether or not that feed or feed ingredient can become infectious and cause infection in naive populations, the data on the left is the same data that we just saw. However, we're simply looking at the first and last data point with a simple linear regression over that 42-day time span. Some work by Dr. Schumacher at K-State has determined that the minimum infectious dose in feed for porcine epidemic diarrhea virus is a 10 to the first TCID 50, which correlates within feed to a CT value of approximately 37. So we can see that it's very important to consider that that minimum infectious dose isn't a line straight across over time, that in fact is just at a single time point within these experiments on day 0 of the study. So it's very important to consider moving forward and determining quarantine periods, if you do use a minimum infectious dose type of method, to consider that the minimum infectious dose is at a single point in time and can't be extrapolated beyond what the original data set out to determine. So next, within the graph on the right, we can see the MID arrow at day 0 at a CT of 37, and the red arrows represent those samples when inoculated in swine bioassay caused infection, whereas the green arrows represent those samples that did not cause an infection in naive pigs. A couple of things we'd like to point out here to further illustrate the importance of time when considering MID. You can see that relatively low CT values in both complete feed and spray-dried porcine plasma are not infectious over time, whereas on day 0 both were infectious. And additionally, we can see that based on certain ingredients, plasma versus complete feed, they do have a difference in the ability to cause an infection in naive pig populations relative to their dietary composition. And to begin to further that, the last slide, and still thinking whether or not feed or an ingredient can become infectious, we have some minimum infectious dose data from Dr. Schumacher relative to PED, as well as some data generated over the years with African swine fever virus. And again, with these data, it's important to consider the way the original studies were conducted and be very careful when extrapolating beyond what the original data set out to determine. And finally, some of the approaches to excluding or preventing pathogen from becoming infected within our feed or feed ingredients. One of the best methods that we highly recommend to our feed mill manufacturers, veterinarians, and nutritionists is the simple principle of exclusion. We know through research that once pathogen gets into a feed mill, it's very difficult to get out. So we strongly advocate excluding the pathogen of interest from our production systems to begin with. Our group at K-State, as well as others, have collaborated and put together a swine feed mill biosecurity audit that nutritionists, veterinarians, and producers can use to help assess the risk of disease transmission within their feed mill production facilities. And this, as well as a multitude of other great information, can be found at our ksuswine.org website. And finally, some additional recommendations regarding limiting the amount of pathogen and reducing the spread of becoming contaminated would be simply to limit our animal proteins within our feeding programs. Both PED and African swine fever virus show an affinity for survival as well as transmission in porcine-based ingredients. And we believe that when implementing animal protein-free feeding programs, we can have little to no impact on pig performance, as well as reduce the overall feed cost of the diet. So finally, when considering how we can mitigate if a pathogen does become exposed to a feed or feed ingredient, how we can mitigate that risk. One principle simply would be quarantine, and the images on the bottom right are we've already discussed through early in the presentation, simply present here to illustrate the challenge of extrapolating some data that we have and being able to make solid recommendations. Although that's a great approach and necessary to move forward as an industry, it's very important to consider some of the limitations of doing so. And other mitigation strategies include the use of point-in-time mitigation, which include diluting below a minimum infectious dose, irradiation, as well as heat treatment. The data represents some poultry data where poultry feed was inoculated with salmonella, and as you can see, when the feed was pelleted, we see a reduction in the quantity of salmonella present within that feed, thus indicating that pelleting and thermal treatment does a great job of reducing pathogen load within a feed or feed ingredient. However, the problem with our point-in-time mitigation strategies is they work great at a single point in time, however, they are prone to subsequent recontamination within the feed manufacturing facility as well as within transport. And finally, one of the other mitigation strategies would be residual duration of activity approaches, where we can add various compounds to the diet, and we would expect that they would remain active at reducing the pathogen load over time. And much of this work has been done specific to PED, as well as we're beginning some research with African swine fever virus. But at this point, we don't have a tremendous amount of data that's available to make recommendations specific to some of the newer foreign animal diseases of interest to the U.S. So at this point, we don't have the solid data to make recommendations. However, much of this work is continuing to be performed. So finally, it's very important to consider much of the discussion here this morning will be specific to feed and the role that feed mills can play potentially in disease transmission. But it is important to consider that it's one of the many potential vectors of pathogen spread. We do have limited information about all the steps within our feed safety cascade, and it's important to consider the entirety of information in context and how it all plays together to ultimately reduce the risk of disease transmission. We believe that our recommendations would be to exclude high-risk ingredients from high-risk countries as our current best strategy, as well as improve supplier communications to understand where our feed and feed ingredients are being originated and sourced from. We advocate ramping up our biosecurity measures on both the feed mill as well as transportation and on the farm level, as well as considering feed or environmental testing, as well as considering proactive mitigants. At this time, as we mentioned, we don't have the specific data to make these recommendations. However, we do have a lot of research ongoing, great research, and please stay tuned as we do learn more, and hopefully in the future we can make some more specific recommendations. So if you do have any questions, afterwards we'll be able to have a great discussion, and we do have some great resources available on our ksuswine.org website. Frequently asked questions regarding ASF and CSF is one of the newer documents that's available, as well as many other feed safety resources. So thank you very much for your time this morning, and we look forward to the other great presentations and hopefully have some great dialogue following the presentations. Thank you.